Where does it all go? You just push the lever and it's gone. So how does it all work? Can anything go down there? Are there even any rules? And is the sink any different? The bathroom sink, the kitchen sink? Actually, there is no difference. Sink, toilet, same thing. Behind these walls and under these floors, all the drains meet up in a single pipe and head toward the sewers.
Going about our everyday lives, we use a lot of water for drinking, washing, cooking, going to the toilet and much more. By using this water, it becomes polluted. The wastewater we produce is known as sewage.
Everything that leaves the house through the main drain pipe meets up with the sewer, right down here. In some places, it's a combined sewer, both wastewater and stormwater. In other words, everything from inside your house and everything from outside your house, rain, whatever, goes into a single combined sewer.
Together with rainwater that runs off roofs and roads, sewage is washed, flushed or drained into sewers. The underground network of sewers that collect all this wastewater and transports it to the sewage works is known as the sewerage system, and the area it drains is the catchment area.
All of it heads towards the wastewater treatment plant. In some places, the sewers are separated, one for wastewater and the other for stormwater. In that case, only the wastewater heads towards the wastewater treatment plant. The storm sewer goes straight to the river, untreated, because it's only water, right? Actually, no, it isn't. All the chemicals that you put on your lawn or the soap with all the phosphates that you wash your car with all head out in the storm sewer if you've got a separated system. Straight into the river. All the wastewater ends up at wastewater treatment plants. The purpose of these plants is to remove all solids and pathogens, microorganisms like bacteria and stuff, from the wastewater, so when it gets reintroduced to the river, it's cleaner than when it arrived at the wastewater treatment plant. When it arrives, coarse screens remove large solids, rags, and debris from wastewater and are immediately disposed of. It's here that you see some of the most ridiculous things people have put down their toilets, drains, and sewers. At least this stuff made it this far. Some things that the water can't dissolve end up stuck in the sewers, leading to sewers being clogged and homes being flooded. After this, fine screens are used to remove the smaller material in the same way. Next up is grit removal. Grit includes sand, gravel, and other heavy solid materials that are heavier than the organic solids in the wastewater. Removal of grit happens by getting the wastewater to flow in a spiral pattern. Heavier particles settle at the bottom of the tank, while lighter organic particles are suspended and eventually carried out of the tank. From there, that water is sent into a settling basin. This is where suspended solids settle out and floating scum is removed by skimmers. Scrapers in the tank move continuously along the bottom to deposit the raw sludge into hoppers, which is sent to a nearby plant where it's made into pellets for fertilizer. After the settling basins, the wastewater is sent to the next step by an Archimedes screw pump, which forces the liquid upwards. The revolutions raise the water thread by thread until it comes out at the top of the cylinder. There, it is met by the fine curve screen, where small items that have made it through the initial screening process are removed. Things like fruit and vegetable stickers. They don't dissolve and they clog up the system, so when you're peeling them off, throw them in the garbage, not down the sink. Now it's time to get the stuff you can't see. Some of this work is done by biological aerated filters. Essentially, what happens here is that good microorganisms attached to porous rock eat up the bad microorganisms. The wastewater is pumped up through the rocks and the bacteria in the water sticks to the rocks. Bubbles are pumped in to keep the good bacteria alive and working. The clean water goes up and the rocks with the bad bacteria attached to them go back down. This cleansed water then flows into a channel on its way to be treated by ultraviolet light.
This innovative plant collects and treats both your wastewater and nature's stormwater, making sure it's safe to return back to the river. The wastewater passes through various treatment steps, including removing debris and contaminants and clarification. Then the cleaned water is returned to the river to re-enter the water cycle. It's important that the water we return is safe for us and the environment, so we can use it today and others can use it in the future.
Traditional sewer systems collect all the wastewater from our homes and offices and send it to a centralized treatment plant. After residents, businesses, and industry have used the water, often only once, it's treated and released into the ocean or other nearby lakes and streams. And many cities are struggling with the dual problem of stricter regulations to decrease water pollution and an ever-increasing volume of wastewater. If we take a closer look at how we use water at home, there are many opportunities to conserve and minimize our own water footprint. First of all, we can reduce our water consumption with low-flow shower heads, modern clothes washers, and other smart appliances. Although our sewer systems are designed to process human waste, we put many other things down our sewer lines, like kitchen scraps, cleaners, drugs, and other chemicals which can get into our rivers and ocean, harming fish and other aquatic life. We should think before we use our drains for waste disposal. The first step in solving this problem is to reduce our own waste. Household conservation and greywater use can significantly reduce the actual volume of wastewater ending up at the treatment plant every day. And it's not just water that we waste. The food scraps we toss down their disposal are mixed with sewage and sent to the wastewater treatment plants where they are separated and disposed of. Many cities have to transport all this solid waste hundreds of miles away for disposal. By composting our kitchen waste at home, we can help reduce the amount of waste that gets trucked away. Many treatment plants can generate energy from solid waste, and new technologies may make it possible to generate enough to operate the plant as well as provide a local source of biofuel. Today's large industrial sewage plants collect huge volumes of water from an entire city and pump it all to a single location for treatment, where it is discharged into the nearest body of water. If we rethink how we transport and process wastewater, new opportunities arise. Many cities are now reclaiming wastewater, that's right, sewage, for reuse in our homes and businesses, or for direct recharge of aquifers. One of the best opportunities for wastewater is recycling it to drinking standards. Potable reuse is the process of purifying our wastewater to make it drinkable. Wastewater from homes and businesses is forced through very fine filters, allowing water molecules through while trapping dissolved salts and other impurities. Potable reuse is an efficient source of water because it makes use of water that is already in our local water system. And it is also good for the environment because it takes impurities out of the system, eliminating the need to discharge polluted wastewater into the ocean. Communities around the country are already drinking it as part of their normal water supply.